Hi there, you're on IGCSE Maths Tutors, and in today's video we're going to explain some applications of differentiation. In a previous video we have shown how to get the derivative of a function dy by dx. We have also explained what we mean by the derivative of a function, and we have discussed one of the applications of differentiation, namely in finding the minimum or the maximum of a particular function. I strongly advise you to view this previous video, whose link is shown now on the screen, before proceeding further with the current lesson. We turn now to an IGCSE exam question that shows a cuboid of volume V centimeters cubed that has a length of y, a width of x, and a height of x as well. Now, the question says that the total length of all edges equals 112, and we're asked to show that v, which is the volume, is equal to 28x squared minus 2x cubed. We need to prove this. So, the first thing that we do is that we sum all the edges that are equal to 112. We find the summation of all of those edges in terms of x and y. Now, first we count the number of edges of length y. We have here 1, 2, 3, 4 edges. So we have 4y plus how many edges of length x? 1, 2, 3, 4, 5, 6, 7, 8 edges of length x. So we end up with an equation that says that 4y plus 8x equals 112, which is the sum of all edges. Now, if we put this equation in terms of y, that is, make y the subject of this equation, we will end up with 4y equals 112 minus 8x, and if we divide this equation by 4, we will have y equals 112 minus 8x all over 4, which is equal to 28 minus 2x. We turn now to the volume, and as we know, the volume of a cuboid is equal to the length times the width times the height. We know, of course, that the length is y and the width and the height are both x, so the volume is equal to y times x, which is equal to y times x squared. However, as we know, y is equal to 28 minus 2x, so if we substitute this value of y into the equation of the volume, we will end up with v equals 28 minus 2x multiplied by x squared, or v equals 28x squared minus 2x cubed, which was what we were required to prove. Now, the second part of the question is quite simple. It asks us to find dv by dx, which is the derivative of the equation of the volume. So if v equals 28x squared minus 2x cubed, remember, to get the derivative dv by dx, we multiply the index by the coefficient of x. So the index is 2 and the coefficient of x is 28, so it becomes 2 times 28x, and the power of x is reduced by 1, so we have 2 times 28x to the power 2 minus 1, and the second term in the equation, we also multiply the index 3 by the coefficient of x, which is 2, so it's 2 times 3x, and we reduce 1 from the index, that becomes x to the power 3 minus 1. Now, if we just work this out, we end up with 56x minus 6x squared, and this is the derivative of the volume. The final part of this question says find the maximum value of v to 3 significant figures. Remember, at the maximum point for v, the gradient, which is the derivative of v, dv by dx, is equal to 0. So if we equate the derivative, which is 56x minus 6x squared, if we equate it to 0, if we take x as a common factor, we will have x multiplied by the bracket 56 minus 6x equals 0, and hence either x equals 0 or 56 minus 6x equals 0. If 56 minus 6x equals 0, then 56 equals 6x, or x equals 56 over 6. If we simplify this, we have x equals 28 over 3. And remember, we're not asked to find the maximum value for x, but rather the maximum value for the volume. So if we got this value for x, we have to substitute it into the equation of the volume. So v equals 28x squared minus 2x cubed. Substituting for x with 28 over 3, we are left with 28 multiplied by 28 over 3 all squared minus 2 multiplied by 28 over 3 all cubed. If you work this out on your calculator, you will end up with v equals 813.037 centimeters cubed. Now remember, we have to get the answer correct to 3 significant figures, meaning that we're only allowed to display 3 digits. So this leaves us with 813 centimeters cubed, and this is the maximum value of the volume. I hope you found the explanation useful and clear. If you still have questions, you're welcome to leave them in the comments section below. If you liked this video, please give it a thumbs up, and meanwhile, I'll see you again in the next video. Goodbye for now.